Okay, let's do some subtle tricks now. Just your general work type questions, but with just some subtleties that you may or may not get. We'll look at 3 of them. First one we're going to do is where we get a switched orientation, kind of a look that we're not used to seeing. And in this case, let's take it as a, here, let's have a boat, and maybe somebody's swimming in the water with that boat. Maybe you got that rope in your teeth. And we're just going to use numbers that we know. Let's take that to be 17 degrees. The boat moves 30 meters, and there's a frictional force applied by the water of 250 newtons. Now we've had all these numbers before, so when we plug everything in, it's going to be an answer that we've already seen. So work is force times distance. In this case, you're swimming upwards, so everything applies up, but everything is exactly the same. It's still going to be 700 cosine of theta, which is 17 degrees, and we're going to subtract off our force of friction, which is 250, and it moves 30 meters, so that when everything is plugged in, 669, subtract 250 times 30, and that ends up being 12,582 joules. That is work done on the boat to move it from here to there. Now if we wanted to look at it in terms of the swimmer, how much energy does it cost them to move the boat from here to here? We add it there. So really, if we wanted to look at it in that situation, we would go 669 plus 250 times 30, and you would end up with an answer of 27,570. Okay, so there you go. This is the work done to move the boat, and this is the work done by the person swimming while moving the boat. Excuse me. Second question. This one's pretty easy in terms of formula work, but again, it's subtle. In this case, let's say that you got a box here. Who cares what the mass is? You can apply some ridiculous force. Let's apply 190,000, 190 million, 190 billion newtons. Okay? Huge amount of force. Work equals force times distance. If this mass moves no distance, that means if it ends up moving 0 meters, well, if you look at your formula, I can plug in my 190 billion, and I'm going to plug every single zero in. How many zeros is that? 9. 3 more. There. And when I times up on my distance, 1 more 0, you can check it out in your calculator. Anything times 0 is 0. So your total work done, 0 joules. That means, since this thing didn't move, no energy was transferred to it. Doesn't matter how much force you apply. Okay? So that's just a no distance type question. Third question. And I may run out of room here. In fact, I'm going to run out of room, so I'm going to change sheets. This is a kind of question that you see sometimes where you're going to be given your information, massed object, it's going to get pulled off with 900 newtons. This time though, I'm not going to tell you what your theta value is. We have no idea what that 900 newtons is actually angled at. I'm going to tell you though that there's a force of friction of 400 newtons. I'm going to tell you that 15 meters, and the energy transferred to the object, or the work done moving it from here to there, is going to end up being, let's say, 5,000 joules. Okay, so when we do our work equals force times distance, F net times D, you're going to end up, going 5,000 equals 900 cosine of theta. I don't know theta, but I have to subtract it from 400, and I have to apply that over 15 meters. So I'm going to run my 15 through both sides. I'm going to times it here, I'm going to times it there. So I'm going to go 5,000 equals 900 times 15 cosine of theta minus 400 times 15. When I plug all this in, 5,000 equals 900 times 15 is 13,500 cosine of theta minus 6,000. And now I'm going to solve this thing for cosine of theta. So I'm going to go 5,000 plus this 6,000. And I'm going to divide it by 13,500. And that leaves me with cosine of theta. When I do this, I end up saying that cosine of theta equals 0.81. And when I do a second function of cosine, I get my theta value to be approximately 35 degrees. So 35 degrees is what this had to be right here. Here you go. Now that's the work done to move it from here to here. Totally different question if we want to know the amount of work done by the person doing the pulling, there being a plus sign right there.